So there's no point in me just waiting for all of you, right? So if I mention 3:50, so please turn out by 3:50. You didn't have any previous class. So there's absolutely no excuse of coming late. So the time we spend in just waiting is the time you lose in the additional content that I could have covered, or the more details I would have gone in with respect to any of the content. So it's your loss only. You'll have to figure that out. Okay, so we'll now resume the discussion on conditionals. So previously we had seen the, yes, can everyone please be quiet now? So it started off that we can write statements. So we saw a program of trying to figure out whether a number is greater than 10 or not. If x greater than 10, print greater than 10. Right? So this is a very simple program which we're writing. Here we're using a single if. Yes, everyone, please quiet. So we have written a single if condition here. If some condition, which is a Boolean, colon, print greater than 10. If we run this as expected, with an input of 12, we get greater than 10. With an input of 9, program complete. It does not enter into the scope of if x greater than 10. Right? So this is known as a one-way condition, because there's only a single if. If this condition holds true, then something happens. Otherwise, nothing happens. The program just continues. So yesterday I was drawing some flowcharts, but as all programmers are, I'm also lazy. So I didn't want to keep drawing, and my handwriting is also not very neat. So I thought of if we can figure out some automatic way of drawing flowcharts. I will just show that to you. But this is a very cool project. If someone is getting bored in the course, you should try and implement this from scratch. So write a program which accepts a Python program as an input and creates a flowchart of the kind that I'll create. So this is a simple Python program that I've created. And there's another Python program that I'm invoking, which gives me certain output. And there is a website which can then pick up this output. And it can create, okay, so let me actually just modify the program. Right? So this is the flow chart corresponding to the program that we'd written. It starts with x equal to 9. If x is greater than 10 is what you're checking. If it's true, then it's printing greater than 10, it's printing yay. So if you're noticing, there is a slightly different format to the one which I'd mentioned yesterday. Here prints are shown in this rectangles with a border, whereas normal processing statements are shown in regular rectangles. Conditional checks are shown in these diamond boxes. So if x greater than 10, so that's why we're calling it a single way or a one-way conditional, because there's only one thing which happens. If that thing happens, then something. Otherwise, you're not bothered. If x greater than 10, then do something. If x is not greater than 10, then no, and that just comes down to complete the execution. So I'll also keep saving these images so that it's easier for all of you. So this is oneway.png. I'll copy that PNG over here, and this is another cool thing about Jupyter Notebooks. You can embed some images here also. Okay, I don't know if the path is. This should have worked. The image should have rendered here. For some reason, it's not rendering. Let's just look at Markdown. Yep. So the text I've written is perhaps okay. Okay, so it's not got that particular file here. Okay, for some reason it's not getting updated. But anyway, so once I render this, once I end this class, I'll put the corresponding flowchart here with the program so that it becomes easy for you. So what is the module? What is what? Which of them? So that is a separate library which you can import or you can use as a module to directly just. So it's called PyFlowchart. It accepts as input a Python program .py, and it can then convert it into some representation for a graphical model. Right? There are various other applications you could have used, but this is just one of them. You could have used a program called PyDot or dot. You could have also used GraphViz. This is one such program which gives in a specific kind of a format, and then this is not going to be asked in the quiz or anything. This is just for visual understanding. So this was a program which just has a single way conditions. We could have had something which is multi-way conditions or two-way in this case. If the condition is true, do something, else do something else. So this will print less than or equal to 10. Right? As expected, with x equal to 9, this prints out less than or equal to 10. We can create a new program. I'll just call it two-way.py. And I'll run the same program. By the way, I don't know if you've noticed, I'm calling Python -m or Python -m, the name of a specific module, and I'm running something. So you can also just read through this, how to invoke different modules using the command line. Again, I won't expect this in any of the quizzes, but just a fun thing to know. So this just returns me some text. I'll again copy to flowchart.js. Okay, so for some reason, okay, this is the correct flowchart indeed. So if you notice in the previous flowchart, if x was greater than 10, then in the yes, you were doing something. In the no branch, you were not actually doing anything. So second. Less than or equal to 10. Okay, it seems to be wrong. Okay, for some reason, the Python program didn't sync. Okay. Right. So if you see this program, it's slightly different than the previous one. In the previous one, we said if x greater than 10, in the yes branch, you're doing something. But if x is not greater than 10, in the no branch, you had absolutely nothing. In this program, in the no branch, also you're printing something, or you could have done some other command. You could have done something more useful. Right. So it's a slightly different variation. Previously, you had a single if, now you have an if and an else. So let's just save this figure also. Okay, so this was two-way. We could have also now done a multi-way. So we have looked at x equal to 9. If x greater than 10, we can print greater than 10, let's say. Else if, so previously we had if, then we saw if and else, and now we're seeing if, else if x less than 10, print less than 10, else print equal to 10, right? So the program is not very different, but we're looking at three keywords now regarding conditionals. If, checking at a condition, doing something. Second is else if. So if the first is not true, then only it goes in else if, right? But if the first is true, it is naturally not going to go in else if, right? So this is how, again, in natural English you would speak. If the weather is good, I'll play. Else if the weather is not good, I'll not play, right? These two conditions are mutually exclusive. You can't have x greater than 10 and x less than 10 at the same time. So we're looking at the flow chart for this. Right? So if you see that the flowchart has now changed a little bit, x equal to 9. If x is greater than 10, then print greater than 10. If x is not greater than 10, so again, this is mutually exclusive. You can't have both of them occurring at the same time. Then you check, is x less than 10? Then you print yes, or then you, if it's less than 10, then you print less than 10. Otherwise, you print that the number is equal to 10. Right? So using these three, you can do various kinds of conditions checking. If, else if, and then else. Right? The logical way to think about them is within if you check the first condition. Else if the first condition is not true, then you check else if something, if some other condition is true, and then whatever is left, you keep that in else. That is assumed in else. If, else if, so else if is written as elif and then else. So any question in this? You have to be a little louder. How does? Shout. Okay. So if we use if instead of elif, which is one of the question in your exam also, in the worksheet also. So we go back to the notebook. Let me just save this. Okay. So if we go back to the program, so this is the correct program, and let's just run this. For x equal to 9, it prints less than 10. For x equal to 10, as expected, prints equal to 10. For x equal to 11, prints greater than 10. Right? So this program seems to work correct. Now let's go back and then just modify this program. Right? So do you expect a different output? Why? X equal to 11. Let's just go over the flow. So let's see. It prints greater than 10 and equal to 10. What happened? So firstly, whenever we talk about if else, it does the matching of if and else, ifs and elses, right? So this else is now corresponding to this if, right? So think about the flow. Actually, let me just draw a flow chart for this, and that way you'll understand it even better. I just call it wrong.py. Okay. X is 11, it will print 10 if X is actually just sometimes just compresses those conditions. So let me just add some dummy statements also. Right? So X equal to 11. If X is greater than 10, it prints greater than 10, it prints A, right? And then it again checks if X less than 10. So firstly, does it make sense to check if X less than 10 when we have already checked if X greater than 10? Yes, no? So if X is greater than 10, then in the NFX, so it will either be greater than 10 or less than 10, right? So we could have just put something in the no branch, right? Rather than having another if, which now checks if X is less than 10. So any input will be either working in the first branch or it will go in the next second branch. These are mutually exclusive events. So if X less than 10, then it checks that if X is not less than 10, it prints equal to 10. Otherwise, it prints less than 10, right? For an input of 11, X greater than 10, yes, right? X greater than 10, yes. So it's printing out, in this case, greater than 10 and yay. Is X less than 10? X was 11. Is X less than 10? No. So then it goes in this condition, it prints out the no condition. What is corresponding to the no? In this case, it's print equal to 10. Right? So therefore, the else that you had, this else, right, gets paired up with this if. This else gets paired up with this if. Right? Therefore, this program is wrong. Could you do some slight modification to this program to get this working without using an LF here? What if you wrote LF? Is this a correct program now? Is this the correct program now? Why not? So condition is required. Is this the correct program now? Let's just run this for various inputs. With 11, it prints greater than 10. For 10, it prints equal to 10. For 9, it prints less than 10. Right? But this is just unnecessary. You are having multiple checks. This could have been much more efficiently done with this logical flow, because we have greater than 10, less than 10 are mutually exclusive. Only one of them will happen at one time. So from the no branch, you can directly just tag along the other branch, other question. Does everyone understand this? Any further question on this? You could have just used a if also. So it works with 9, works with 10, works with 11. Right? But all of these are unnecessary. So the way to think about them is, why I'm saying this is unnecessary, you should be just drawing the flowchart for these. You'll get a lot of clarity. There are unnecessary nodes, unnecessary questions being asked. And we'll get to this. Some of you were asking that your programs are becoming very large. So this is one place where you can make your program smaller. You can understand that how you can order these different conditional checkings. Right? No point in checking all of them separately. If X is greater than 10, it cannot be less than 10, right? So therefore, you could have just put, if X is greater than 10, it's not, then else if, I'll just keep it this way as an example of something you can get working, but it's not the optimal way to do it. Right? Other questions at this point? You'll have to be really loud, hard to hear. What was taught in the morning about short circuiting? Floats. So we'll come to that. Just hold on to that question for a few minutes. We'll first just finish this conditional. We'll come on to the floats also. Yes, any question regarding this? No. So that was the first program that we wrote. It only had an if. So if you don't care about the case when the condition is false, you can just have an if, right? Let's say if our goal was only to check whether the number is greater than 10 or not, which was the first program, right? So let me actually just, do I have, right? So the goal of this program is only to check whether the number is greater than 10 or not. Can you give me other examples of things where we only want to check a specific thing and not both the things? True, false, where do you use that? If you want to check whether a number is even or odd, right? I just want to check whether a number is even or not. For example, I don't necessarily care about the else part there. For example, if the question was x equal to 5, if x modulus 2 equal to 0, print even. I just want to check whether it's even or not. Otherwise, default, if nothing is printed, it's assumed to be odd. Nothing is printed, x equal to 6 is even. Right? So we could have just used a single condition because we again know that the output is mutually exclusive. You'll either have an even or an odd number. But with grades, this is not the case. It's not necessary that you'll either have A or everything else. Right? Yes, other questions? Okay. So if we don't have questions, we can then go on to the rock, paper, scissors question. So all of you have already perhaps solved this in your lab, but we'll see that if we can optimize that code. Right? First, we'll just look at very naive way to solve that problem, and then we'll gradually keep on improving that. And finally, we'll see that if we have a better algorithm, then we can have a much better solution, end up with a much better solution. Right? So firstly, we just want to clarify the rules. So rock beats scissors, scissors beat paper, and paper beats rock. Just for simplicity, let's just assume each of them as in lowercase, right? The way we are going to set up this program is, so in the lab, you were looking at some random choices. For now, let's just simplify that. Let's just assume that we have two choices, user and computer, right? So let's just assume that user is, let's just hard code some values. I've already mentioned this, that this is the first thing which I generally do in programs. Hard code some values, get the program working with different conditions, and then use the user input. And then after that, I would look at the randomization. Right? Let's say U is rock and computer. So U means user and C means computer. C is, let's say, scissors, or I can just, let me just use the initials just to make it easier. Right? So we have these conditions, right? These are the three playing conditions, but we have to be talking in terms of the user and the computer, right? So let's just write a large program for this. If U equal to rock and computer equal to rock, then what is the result? Then the result is a tie, right? Then should I be writing a if or a else if? Else if? LF user equal to rock. By the way, sometimes I'm using a single quote, sometimes I'm using a double quote. So I would just suggest to use double quotes. If user is rock and computer is paper, then who wins? Who wins? So user is rock, computer is P, who wins? The computer wins, right? We also want to be giving who wins and using what. So let's just say that C wins and C was using, C was a P, was a C, and the user, the computer had a C and the user had a U, right? So let's just first try the small program. right? So nothing will get printed at this stage because for us, the user was R and computer was S, which does not match any of these cases. Let's just try these two cases. Now we have a tie. But if user was R and C was paper, C wins, computer wins. Computer had chosen P, user had chosen R. Let's just try and write out the other conditions. So if you notice, there is a pattern to what I'm using. I am first writing out fixing U equal to R, and then modifying C to be either rock, paper, or scissors. So user is still R, and C is now scissors. Then who wins? Who wins? User wins, computer at C, user at U. So this part still remains the constant, right? Okay. So we're done with the case when the user had chosen R, right? So let's just verify this. So if it's R and C, R and S, user wins. So we've covered out the cases when the user was R. If user equal to, so rock, paper, scissors, P, and C equal to R, who wins? Who wins? User wins. Could have just put them. LF. So this program is already becoming big, as you've seen. U equal to P and C equal to P, then it's a tie. And if U is P and C is S, who wins? Computer wins. Okay, so thus far we have checked 1, 2, 3, 4, 5, 6 conditions. How many more conditions will we have? User is equal to now rock, paper, scissors, and C equal to rock. Who wins? Yes, who wins? Okay, so rock, paper, scissors and paper, user wins, and scissors is a tie. Right, so this program does not even fit into a screen. Right, so now let's just try this for different combinations and we can just verify. If user is rock and computer is scissors, user wins, rock beats scissors. Like I've not written the entire string as was asked in the quiz. You can do that. I'm trying to show the concept of how we can improve upon the conditions we're using. So let's just try out different combinations to ensure that we're correct. R and R would have been, okay. What do you think happened? Okay, I don't know what happened. For some reason it. So R and R gives a tie. S and R. If user is stone and computer is rock, then computer wins. Right? C wins, computer wins. So this program seems to be okay thus far. Right? It's a very big program. We have 9 conditions, but it's correct. Right? Now, how do we improve this program? Yes. Okay. 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 But the number of conditions is still remaining the same in that case. How are you reducing the number of conditions? Okay. Okay. But you still have an OR. You are including that OR, right? If you're not checking it here, you're doing an additional OR. Okay, so someone said that, yes. Okay, so I'll come to that solution. I don't want you to be giving that solution. That's the, we'll build up to that. So that is what he's planning to answer is the most optimum solution. But I want to reach there slowly. So the first method we can quickly, the first thing we can quickly improve is that when do we get a tie? When U equal to C, right? At that point, we don't even care whether U is rock or paper or scissors. If U equal to C, it's a tie. So let's just have the second version of this. By the way, if you're brave, let's just try and write this into a new program. And let's say rock, paper, scissors 1.5. And let's just give it something U equal to C and C equal to P, let's say. Rock, paper, scissors 1.5. Let's just copy this huge program. You see this flowchart? If user is R and C is R, then yes, it's a tie. So you've tested all the possible conditions. So the number of flowcharts is number of conditional blocks is 1, 2, 3, 4, 5, 6, 7, 8, and then finally you're printing out 9. So we can first make a slightly more efficient version of this, which handles all the ties together. So first we check that if U equal to C, just print a tie, right? Else, so now we can remove the conditions when U and C were the same. So remove the conditions, remove the P and P, and remove the S and S. Right. So the program is now significantly shorter. We have reduced a few conditions. How many checks do we now have? 1, 2, 3, 4, 5, 6, 7. We've gone down from 9 to 7. Why not from 9 to 6? We said that there were 3 conditions in which we had a tie. But we still have to check whether the user is equal to the C or not, right? So we have to have a condition for the tie. So it's not 9 minus 6, it's 9 minus 6 plus 1, because now you have added a new condition to check for the tie. Okay, how can we improve this further? Yes? Any suggestions on improving this? Barring the solution that he was giving, which is a really neat solution. Is this the best we can do? We can use nested if, which is not necessarily better, but it's a different concept which I was planning to teach you. So we have seen that. So if we notice these conditional checks, U equal to R and C equal to P, right? So let's just break this thing down. Let's just see the case. So let's just check the condition when U is R, right? If the user has chosen rock, how many conditions do we now need to check for the computer? two conditions because we've already considered the tie. So if C equal to P, then what is the output? Can we directly write an else here? Why? So we have first checked if U equal to C, right? So we have already checked R equal to R condition. And in this case, we are checking the R and P condition, which means that the only condition now we're left with is R and S, right? Which can directly just come in the else. We don't need to write else if again. So else user wins, right? So this is corresponding to computer has scissors, right? So the code is now slightly different. So this is what I want you to first look into carefully. This is known as a nested conditional. Right? If U is equal to C, then you print a tie. Else if U is equal to R, and then you have again some checks. Is C equal to P or is it something else? Right? Do you see the concept of nesting? So we have moved down one indentation level. Previously, all of the prints, you see, were at the same level. Right? Now we have moved on to a nested, which means we have another level of hierarchy. We first just check whether the user is R or not. If the user has chosen R, we check, has the computer chosen P or has the computer chosen scissors? Right? So instead of so think of this statement, U equal to R, and then you're checking if C equal to P, right? So in fact, if you notice this, I want you to very carefully notice this pattern. U is R, C is P, print C wins. U is R, C is P, print C wins. U is R, C is P, C wins. Right? So in this else if you had this and, so you were doing this expression of checking both in one time. What is user? What is the computer choosing? In this case, we have made this slightly different. We have first, we're just looking at what the user has chosen. And then we check based on the user has chosen, we just want to check what the computer has chosen. It could be either a P or a scissors, given that we have already checked for the type. Is this program better? Not necessarily, because one nested conditions sometimes become harder to read. Right now, you have to look through this nesting. You have to look through U equal to R, C equal to P, and if you don't follow the entire logic, you may not even know why is it an else here. What could we have expected? I could have made that slightly easier to hand and have written else if C equal to S, right? But then that is kind of defeating the purpose. So in this program, we see that it's slightly better, but not necessarily. So the better in the case whether you like hierarchy and you like nesting, but in terms of the overall logic, it's not any different, right? So we can just complete this. So we go to LF again. Now U equal to rock paper. What is the value of C we want to check? R else something. So if C is R, so we're looking at the condition user is P and C is R. User is P and C is R. We say that the user wins, else the computer has to win. And then, can we write an else here? Yes or no? So now look at the thing which we are checking. What are the possible options for U? So first, we've just checked whether U is equal to C or not. In that case, we have just returned okay, can anyone figure out a bug in this program? If there's any, can figure out a bug? The way to figure out a bug is to consider all possible scenarios. Yes. No? is to think about all possible scenarios. Even if U is equal to C, it will execute which statement below? So if U is equal to C, and if U was R, C was R, are you saying that we enter into this condition, else if U equal to R? So let's see. So let's consider the case U is R and C is P, right? So is U equal to C? No, it does not print a type. If is U equal to R? Yes. Is C equal to P? Yes. So this will then execute. Of course, since this else if has completed, you entered into that. You will not enter into this else or this else, this else if or this else, right? So similarly, if U equal to C, right? So let's say if U equal to C equal to both were a rock. So in that case, we print a type. We don't enter into this. We don't enter into this. We don't enter into this. Right? Does the program look okay to everyone? So as you're noticing, it's already becoming a little complicated, a little convoluted, right? Perhaps it would have been better to just leave it to version 2, which just handles the ties separately, and then it just prints out the 7 conditions, right? But let's me just complete this program. Else if, so now the user is rock, paper, scissors. So if C is equal to rock, then the user wins. Else the computer wins. So C is R. What is U now? Sorry. So U is rock, U is paper, U is scissor. So if user is scissor, computer is rock, then computer wins. Otherwise. So as you're noticing again, as I'm demoing it live, this is getting very hard to maintain what is happening inside which branch. And I'm making mistakes here, right? Which were not the case in this kind of a program, which was the earlier version. So we should definitely try and prefer this version, which is the previous version. But this is just showing what a nested if else can do. So if you check for a certain condition, you can then check for certain subsets of conditions under that specific condition, right? So this is called nested conditionals. Right. Okay. LF have I done wrong? Right. So this program also works. Okay. Now can we look for some better solution? The hint is to think about encoding the rock, paper, scissors with certain numbers. And just to give a further hint, let's just use the following numbers. R is encoded as 0, P is encoded as 1, S is encoded as 2. Right? So we're just using this encoding. 0 means, so whenever we write U, so user will now either enter a 0, 1, or 2 instead of entering R, P, or S, or rock, paper, scissors. Like this is an encoding that we're using. So I want you to think about this. We're using this encoding. So can you now create a table under mentioning zeros and ones for user and computer? Figure out the cases where the computer wins. That's an easier problem than to figure out the case when the user wins. Another hint is to use modular arithmetic. So use the modulus symbol, right? So with all these hints, I want you to try and get this rock, paper, scissors to figure out who wins, user or the computer wins, right? So use this encoding and use modulus operator somehow to figure when the computer wins, right? So the goal is to reduce the number of condition checkings that you want to do, right? So at this point of time, it's like a puzzle. Think about this for 5 minutes and we can then discuss. Yes. Which LF? Which LF? U equal to P. Yes. If you're writing it that way, then there's no point in making it a nested condition. So nested means you check only for one and then you nest it and then you again check for the remaining conditions. Within this condition, you first check what is the user, right? Then you check based on the user whether the computer is something else and then you make the decision. Other questions on nesting? For certain problems, nesting makes a lot of sense. For this one, it probably is a little too complicated. Okay, think about this problem. Yes, already figured out, or is it a question? Okay. Is it working? Can you just write a program and check? Okay, all the conditions. Okay. Can you also try all the possible conditions to see? Random is, you may not be able to test all the conditions. You can just manually type out all the conditions. Yes. So you need to use your pen and paper. You can't, you may or may not be able to completely work out this using just your head. So in the paper, the first step that I'm suggesting is create a table of all the possible combinations, user and computer, and write down these numbers, 0, 1, 2, 0, 1, 2, so on and so forth. And then figure out under what conditions is the computer winning. So someone has already figured this out. You should try with some other encoding. Instead of using 0, 1, 2, what if you were using 1, 2, 3 or some other encoding? But take your time, go slow on this, just create the table. That will help you to get your answer yourself. Yes, anyone else able to figure this out? Don't give up. Try for 2 more minutes and then we'll have a discussion. So those who figure this out should now think that if you were not given these hints, how would you have come up with the solution? What is the specific property of this problem which allows you to come up with the solution? Or some other way? Okay, so let's just hold on to that. I'll show my way and then you can figure out later which of them is the better way to do. Mm-hmm. Yeah. Mm-hmm. Yeah. Right. Yeah. Right. Right. That is the correct answer. Yes. Anyone else able to figure out a solution? Yeah, we'll do that. Do that. So first, is everyone able to create the table between user and computer, and when does the user win, when does the computer win? Right. This again, this might seem to be a very boring thing. You may be thinking of some very complex logic, but often you have to solve complex problems by writing them on a pen and paper on things you can visualize. So maybe let's just use a spreadsheet application. So we have user, computer, right? And let's just see who wins, right? So the user can be 0, 1, 2. Let's keep the user as 0 first. The computer can be 0, 1, 2. Let's just get rid of the ties for now. So the user can be 0, the user can be 1, in which case right? So firstly, does everyone see the encoding? So this means 0 means, let me just add another column. User and string. Rock, rock, paper, paper, scissor, scissor. Whereas C, and let's say we had a computer string. So paper, scissor, rock, scissor, rock, paper. Okay, firstly, can everyone confirm if this table is correct? Yes, is the table correct? Or have I done some mistake? So firstly, you have to think about how we go about creating such tables. So this is not very different from the way we do binary counting. So let's just fix this. Let's modify this, the right hand side, or what we often sometimes call the least or less significant digits. Fix this to the next number, vary these. Fix this to 2, vary these, right? So the changes happen much more often here. Changes happen less often here. Right? That's just creating a table. Of course, you don't necessarily need that. That just helps to ensure that you don't make any mistakes. Okay, so winner. So between rock and paper, who wins? Paper wins or computer wins? I'm going to be using C and U. Right? C wins. Rock and scissors, user wins. Paper and rock, computer wins. Paper and scissor, computer wins. Paper and rock, user wins. Paper and scissor, computer wins. Computer wins and user wins. Right? Thus far, any confusion? Okay, now let's just look at the rows in which the computer is winning. Right? I could have used a filter here, but let me not show you those things. Let me just highlight those rows. Let me just. Let me just bold these. So where the computer is winning. Okay, so now we have 3 rows where the computer is winning. Or alternatively, as I was mentioning, we can create a filter here. We want to be seeing only the rows in which the computer wins, right? So these are the subset of rows where the computer wins. Now, what can you notice between U and C? U is 1 less than C. U is 1 less than C. U is 2 more than C. So the first two rows sort of give you some pattern. Does the third one break the pattern? So, okay, so let me add another column now. I'll call this U plus 1. Right? So now, so previously we were looking at some relationship between U and C. Now let's just look at the relationship between U plus 1 and C. Right? Is U plus 1 equal to C for the first row? Yes. Is U plus 1 equal to C for the second row? Yes. Is U plus 1 equal to C for the third row? No. But then I gave you another hint. Use what operator? Modulus operator. So let's then add another row, another column, which is U plus 1 modulus 3. So if you divide by 3, what is the remainder you get? If you divide 1 by 3, what is the remainder you get? I don't know if they have the modulus. No. So if we divide by 3, the remainder we get is 1, the remainder we get is 2, the remainder we get is 0. Now, what can you say about U plus 1 modulus 3 and C? When both of them are equal, then who wins? Computer wins. If both of them are not equal, who wins? The user wins, right? So we started with a very complicated program, and now we can just create this. If user equal to C, print type elif user plus 1 modulus 3 equal to C, print computer wins, else print user wins. And we'll just be using the encoding u equal to 0, let's say, c equal to 1. Computer wins. Right? So c equal to 1 means rock, paper. So paper beats rock. Right? So u equal to 0 means rock. C equal to 1 means paper. Computer wins because paper beats rock. Right? Of course, there are other tricks I could have shown. I could have printed very beautifully. I could have, and rather than copy pasting all of these things, I could have just created a new variable and just copy paste, just use that variable multiple times. That is very useful because if I have to make any small edits, instead of C wins, if I had to do C capital wins, I have to modify at each of these places, which is very cumbersome. So I could have made use of programming skills. I could have created a variable and done that more intelligently. But for now, this program works. This program is an efficient program. Now, any questions, follow-up questions in this? How do you? Right, so that's where he was also giving an answer. So there seems to be a natural ordering in this. So if you look at rock, paper, scissors, rock beats paper. So rock is beating something. Sorry, rock gets defeated by paper. Paper gets defeated by scissors. Scissor gets defeated by rock. Can you see a cyclic pattern? So therefore, that encoding made sense. The same encoding would not have a different encoding would not have necessarily made sense, and the logic would have been slightly different. So this is a cyclical property. You have rock, which is 0, gets defeated by paper, which is 1 ahead of it. Paper gets defeated by scissors, which is 1 ahead of it. Scissors gets defeated by rock, which in a circle is 1 ahead of it. Right? So it's important to think of this in terms of a circle and not just in terms of 0, 1, 2. And when you mention a circle or when you talk about cyclical things, that's where the modulus operator comes into view. So where else do you think we can use the modulus operator since you brought that question up? So let's say if I tell the time is 1600 hours, can you tell me the time in AM, PM? What is the time? You will do 16 mod 12, and then you'll put PM because it's greater than 12, right? So it's the same logic. It's a clock-like structure. After 11, you'll get 12. After that, you'll again get 1 hour. But the AM, of course, gets converted to PM. In this case, because of the cyclic dependency, R gets defeated by P, P is defeated by S, and S is defeated by R. We're able to use this encoding, right? Other questions? So now you should try and write this program for your labs and quizzes, for your lab and assignments. So that's one thing I'll suggest, that you may already submit your programs, but you should then try and see if you can optimize based on some of the better practices that we're learning in the lectures. For example, this is one such practice. But of course, you will then be asking further questions. So we were using the strings, rock, paper, scissors. But I have in some sense simplified the problem to be using something like 0, 1, 2, right? So I do need to have some kind of a mapping between 0 means rock, 1 means paper, and 2 means scissors, right? Does everyone agree that we need that kind of a mapping? So we can create that mapping using multiple ways. We're not going to discuss the specifics of them. 2 such ways are, one is using a list. List is a collection of objects. And the second is using something known as a dictionary. So if you've already heard of those concepts, then you should definitely try and write this program using dictionaries or lists using this kind of a logic. You can, of course, use some other logic also. Other things you can, I was thinking, you should think about. In this case, I'm using rock, paper, scissors as 0, 1, 2. If I change this encoding to 1, 2, 3, how do you modify the program? So again, I wouldn't want you to jump to conclusions. I would again want you to go slow, create that table which we did, and then manually try and understand that what is the relationship between C, C+1, C-1, whatever is needed, right? So these exercises help you to figure out the logic yourself. In the short run, it appears that you're slow, because you're creating that table, but in the long run, this helps you to build the logic. Yes, other questions? Okay, so then I had wanted to show you something else. So in the mornings, after the morning session, some of you were asking that they had used Java, they had used C++, they had used other languages, but they never encountered the things which I showed in the morning regarding floats. Things like 0.1 plus 0.2, is it 0.3 or is it something else, right? So I'd actually never done this experiment myself. So I wrote a couple of programs, one in Java, one in C. The interesting thing here would be, so the people who have never studied Java, right? For the people who are learning programming for the first time, does this program already look fairly similar to the program you've been writing in Python? Right? There's some long verbose things here, but we have declared some variable A whose value is 0.1. There is another variable of a certain type, which is values is 0.2, and then I'm printing out A plus B. We write print, and Java-like languages, we have println, printf, other functions. So system.out.println A plus B. If I run this program, so I'm going against my own advice. I told you to never use the UI, but in this specific case, the entire operation to write on the command line would have been a little larger. I would have had to figure out the correct path, figure out the compiler, compile the code, get the object, and then run it. Right? But the run will just take care of it. What is the output? 0.3000004, right? So Java also gives you the same answer. So the reason you're getting the same answer in Java is that because both of them are using the same IEEE 754 standard, which was the standard which we discussed. How can we represent decimal points numbers or numbers, floating point numbers using the binary notation? That's the standard is 754, which has a bit of imprecision. Right. Now let's see in C. Anyone here who did C? Who learned C? Who learned C++? Let's see the program in C. Again, for the people who are seeing this for the first time, does the program look again very similar? A is equal to 0.1, B equal to 0.2. The important thing which is different, you may be noticing one of the things which is very different is that we have to define the type of the variable here. In Python, we don't write float A equal to 0.1. Right? We don't need to specify the types. That is done by the Python interpreter and the underlying system. In languages like C, C++, Java, we have to specify the type. That's an important distinction. But if we just run this program, do we again get the same or similar-ish answer? Yes. So at least using two languages, I verified that we can get the same answer as we would have got in Python. The Python one, let me just show that here. Right. So for all the three languages, we get the same answer. So it's the implementation of the floating point logic using IEEE 754 standards. You can read more about that. IEEE 754 floating point representation. You can read more about this on the Wikipedia. It's a big article, but it's good to read. Yes. Any questions? So that was the thing I was mentioning. If students come late, I may have to cut up on some things. So for example, the specific thing which we discussed today, this rock, paper, scissors, using the modular arithmetic, I may have cut it in case we are short on time, because we have already solved the problem using some basic constructs. So it's a request, it's up to you. If you do come on time, you settle down quickly, we can cover more things. It will be more useful for you. Okay, other questions? Or is everyone just raring to discuss the quiz? Okay. Let's just discuss the quiz now. The first question, fix the error. What is the error? You're missing double quotes, right? Print hello world will give you an error because this is not really a string. Right? Any question on this? Okay. The second question. We're trying to compute 365 raised to power 365. We get 0 if you run 365 caret symbol 365. So this symbol is called the caret symbol. In maths, we often use this to denote raised to the power. But in Python, we saw that the symbol for raised to the power is double asterisk. But why do we get a 0? So this symbol is known as the XOR or the XOR symbol. XOR symbol. So go back to operators. What is the help? Right for operators. Right? Do you see the symbol? Bitwise XOR. Right? And again, we cannot cover everything in the class. I'm just showing you that this could have been like you could compute something known as a bitwise XOR or XOR, and you can read about this at your own time. So, but before that, what is the XOR of a number with itself? What is the XOR of 1 with 1 and 0 with 0? 1 with 0. So 1 with 0 gives 1, 0 with 1 gives you 1. That's the XOR truth table. Right? 0, 0 gives you 0, 0, 1 gives you 1, 1, 0 gives you 1, 1, 1 gives you 0. So only when the two inputs are different do you get ones, otherwise you get a 0. So this is happening bitwise. So actually, when you're doing bitwise XOR, think of this 355, right? 365 would be written in a binary format first. What is the 365? What is the number 365 in a binary format? How do you go about that? The exercise which we did in the morning. Right, 365 equal to 256 plus 128, so on and so forth. You write in that way, right? So 2 to the power 7, 8, 9, whatever, and then you'll form ones and zeros, and then you're doing an XOR with the same number, so it will turn out to be 0. So XOR of a number with itself is always 0. The error would have been the way you fix this error is to just use a double asterisk. Okay, now the controversial question. IRCTC wanted to print your sleeper coach number and wrote the following code. Fix the error for them. So now so this is going to be based on assumptions that you make, right? So first, maybe what you wanted to do was S plus, so firstly, S plus 10 will fail. Does everyone at least agree on that? So what you perhaps wanted to do was, so S plus 10 fails. Perhaps you wanted to do this. This is the correct answer. Perhaps if you said that S is a variable whose type is a numeric type, right? Plus 10, where S is defined as a numeric type, and you mentioned that S is some numeric type, let's say 10.5. Well, this is a lesser accepted answer, but I'll still give full marks for this because the seat numbers are not something like 20.0 or just 20, right? You have some alphanumeric character followed by the coach number followed by your seat, right? In fact, you have coach, you have different compartments, right? AC1, AC2, sleeper, luggage, etc. And then you have the seats in them, 32-1, 32B, whatever, right? So that's how you create these. So the accepted answer would have been either S plus 10 or something like this. S comma, that's also okay. S plus str of 10 is also okay. So this is okay. S print S comma 10 is okay. Print S plus str of 10 is also okay. All of these are okay. Of course, when you do this, you may have to use separator equal to empty. Still okay. Ideally, you should have mentioned that, but I think that's okay. I'm not too fussy about that. Any other answer which you'd want That is also okay. I wrote that. Okay. So directly S10 would have also been okay. This is also okay. Happy? Everyone happy now? Anyone who has a slightly different answer, do you want me to still consider? S space 10? Will that work? Within a string? That is okay. So S10, S space 10, all of these are okay. These are all okay. Okay. Question number 4. So we need to do a dry run of this as we did yesterday. A is 10, B is 5. A equal to A plus B means assign the value A plus B to A. At this point of time, A is 10, B is 5. So A is assigned the value 15. Right? So at this point, A becomes 15. And you just store it somewhere. You just write it somewhere. And at that point, you're doing B equal to A plus B. What is the new value of A? 15. What is the new value of B? 5. So B becomes 15 plus 5, which is 20. So you'll print 15, 20. Any question in this? Doubt in this? So 15 and 20, right? Space. If you write, so the comma should not ideally appear. You'll get some marks. You'll get some marks. Print A, comma B. So if you run it, the comma does not come in the output. Sorry? The comma will not appear in the output. That is wrong. Okay. Question number 5. A equal to 10, B equal to 5, A plus B equal to B plus A. What is the answer for this? This one or this one? The first one or the second one? First one. How do you arrive at that answer? Okay, one at a time. Yes, someone. Yes, go ahead. Go ahead. How do you arrive at this answer? Sorry? A little louder. Commutativity. So, just one second. Yes, go ahead. After rejecting the second one. The second one is actually not wrong. So it could have been a Unicode character. We've not studied that. But that could have also been a correct answer. So it's not wrong. So I think many of you will get the correct answer for this with the wrong logic. Right? So the answer is correct. It should be the first one. So whenever we discuss about, so just consider this line, A plus B equal to B plus A. What are the mathematical operators we're looking at here? Plus, double equal to, and plus. So we have multiple operators. What do we need to consider? The precedence. Did anyone consider the precedence and get the answer, or just everyone just got lucky? Lucky, right? Let's go to the operators again. Just one second. Let me show the precedence first. So let's look at the precedence of the operators. So plus and minus are higher precedence than equal to, right? Therefore, plus will happen first, equal to will happen later. Therefore, when we have this line, if A plus B equal to B plus A, this will get translated to if A plus B equal to B plus A, right? Then you'll put the value of A plus B, which will be some value, and then you'll put the value of B plus A, and naturally both of these will be the same, right? So again, sometimes in programming you can get lucky. So sometimes you'll have this experience that you look at your code, you'll maybe getting some 10 errors, 15 errors, whatever, especially with people who have written C, C++ or Java like code. Sometimes you will end up with a large number of errors. You're very happy that you sit in with a high degree of concentration. You figure out a bug in the program, you correct that, the number of errors becomes 500. Anyone experience that? You fix the bug, you correct the problem in the code, the number of errors increase, right? So there are memes going around this, that programmers, sometimes they think that why is the program working, and sometimes they think why is the program not working. In both the cases, they're always doubting themselves. Right? So in this case, the operator precedence was important. but that does not matter in the for you because you still got the correct answer. But for the future, you should be thinking about this for the operator precedence. Okay, any question in this? Yes. Just if in the question they were, so all of them are considered correct code. So I mean that is not a single code. You could have you specified this that this is a single code assumption? Okay, so in that case, we'll still give you marks because you've made the assumption this is a single code. Can't see. I can't see. So let's talk about that later. Let's talk about that later. Single code would have worked. Let's talk about that later. Yes, please, let's not do that. Okay, question 6 is easy or difficult. Let's 6 divided by 2. What is the answer? Because division by default gives you floats, right? We would have thought that the answer is 3, but the answer is 3.0, which is a float. 7th question, 6 modulus 2. What is the answer? 3, which is an end. Right? 6 modulus 2 is the answer is 3, but the type of 3 is an end. Sorry, the remainder is 0. The type of 0 is int. Okay. Any questions thus far? Yes. So question 5, single quote, double quotes, let's discuss that offline because I think most of the people have assumed it to be double quotes. For people who have assumed it to be single quotes, we can discuss it later. As long as you've mentioned it in the, as long as you've mentioned your assumption and you have answered based on that, we'll still get marks. Question number 8. So question number 8 and 9, you should have been able to answer based on the discussion we had in the morning, right? If 0 equal to 1 and, so we discussed that in the morning. If you have the AND operator, if the first condition is false, then you don't execute the second condition. Right? Does everyone follow? If X and Y, if X is itself false, X and Y will also be false. So therefore, Y does not get computed. So therefore, you'll be the output will be a no. No. So you need to hear carefully. If X and Y, if you have two conditions, if X, the first condition itself is false, and since you're using the AND operator, we will do short circuiting, which means that we do not need to evaluate Y. This will overall evaluate to false, right? Which means that print no will get executed. The answer will be no for this. Similar lines, the next question. If 0 equal to 1, X, so now we have X, if X or Y. If X is false, we need to then evaluate Y to figure out if X or Y will be true or not, right? So therefore, 1 divided by 0 equal to 1 will get executed. But can you do the division of 1 divided by 0? So if we do that, 1 divided by 0, you get a specific kind of an error in Python, which is known as zero division error, which means that you cannot divide numbers by 0, right? So therefore, you'll get an error. Right? The program will not execute beyond this line. So the error will come on this line itself. So the program will just stop at that point. These lines will not get executed. Right? Any question in this? So we discussed the concept of short circuiting in the morning. This question is just about that. Question number 10. What is the answer? Not equal to? Any doubt in this? Right, we just saw this a few minutes back. So I think the most ideal answer I would have expected is perhaps I would have been more ambiguous in my answer. I would have said that this is really up to the floating point precision, and we should not be doing comparisons this way. This may evaluate to 0.3, this may not evaluate to 0.3, that is unknown. I would have perhaps written that way and been on the safer side, because 0.1 plus 0.2 does not give you 0.3. But if you do What if you do, so 0.1 plus 0.2 equal to 0.3, this turns out to be false, but 0.1 plus 0.1 could equal to 0.2. This comes out to be true, right? So the ideal answer in this case would have been that don't use equal to for comparison of floats, use some epsilon as a tolerance. But in this case, we'll still give you marks if you've printed the not equal to. Any question in this? Okay, we come on to the last question. What is the mistake here? So marks equal to input. Firstly, marks is a string variable here. We need to convert it into integer by using int of input. That's the first thing. So I just said that you can make it float. Like, I'm not very specific about that. I'm not very fussy about that. But again, when you're talking about floats, the checking needs to be more accurate. That needs to incorporate the notion of tolerance. Right. So if you've written a float and if not incorporated the tolerances, then that's an imperfect solution. Okay, marks equal to int of input. If marks, so let's just 2 minutes and then the class will be over. You can have your discussions later. If marks greater than equal to 90, then it prints an A, right? So let's say the marks on 95. Let's execute line by line. Marks greater than 90, is it true? 95 greater than 90 is true. Prints A. But then you come on to is 95 greater than equal to 80? Yes. So it prints A, it prints B, right? So it will print both A and B, which is the problem here. So all we needed to do is to change this if to an elif. Of course, some of you would have done some changes regarding the boundary conditions also. You would have done 80, 90, all of that is okay. But so that's another thing you should perhaps sometimes think about the psychology of the exam setter. If this question is of 2 marks, either it's extremely hard or it's expected that you'll have 2 kinds of errors. Not necessarily. We'll have to take that as a subjective call. I can't answer that now without having looked at your answer sheet. Yes. If instead of an F, okay. So change between 80 and 90. That is also okay. That's less optimum, but that is still working. That will still work out. Yes. Yes, everyone, please, just 2 minutes and then the class will be over. Yes. If you've given the correct code, you'll get marks. You get the full marks. Sorry? That is okay. That is okay. Yes. I can't hear you. Please, everyone, just 2 minutes. You'll have to be louder. I can't hear you. Sorry. Everyone, please, just 2 minutes. This is just prolonging this is the class, right? If you can just stay quiet for 2 minutes, we'll quickly finish up the discussion and then all of you can leave. Yes, go ahead. Then it will be wrong. No, that will be correct. If we change the if to elif, that is the answer. That is the answer. Okay, so one last thing, which is related to this specific question. When we're talking about grades, so I thought this would be useful to show. So let's say if a grade is 85, let's say, marks are 85. So in Python, we can also use conditions like if 80 less than equal to marks less than equal to 90, print B, right? So this is known as, we were putting it in a specific range. So if this is basically equal to if marks are greater than equal to 80 and marks are less than equal to 90, print a B, right? So this is just equivalent to if marks greater than equal to 80 and marks less than equal to 90. print B, right? So we can write either way. I generally recommend using the first way. It just makes your code simpler. Yes. Sorry. Not allowed. Now you'll be allowed. Now this has been taught in the class. Okay, so we can end the class now. One quick announcement that I usually have the office hours at 3 p.m., which means that these are walk-in hours. You can just walk into the office and you can discuss anything you want to discuss about the course. Okay, thank you.